So here I've got two questions for you here, and I want you to perhaps pause the video after I read them and think about it and write it down in your notebook. So first question is, what force or forces are holding solids and liquids together? It's okay if you don't know, just give it your best guess. And then the second question is, of the three states of matter, which state has the least amount of electrostatic force acting on its particles? So take a moment, pause the video, try and answer these. Okay, so the force that is holding solids and liquids together is electricity and magnetism, which are actually part of one big force called the electromagnetic force. So each particle has an electric charge, and positive and negative charges are attracted to each other. So the particles themselves end up being attracted to other particles. Right? That's what holds things together. Of the three states of matter, which state has the least amount of electrostatic force acting on its particles? That would be a gas, right? Because gases are not close to each other, the particles are moving and bouncing around, so they have the least amount of this force. So let's talk about their arrangement and their separation. We've kind of alluded to some of these things before, but let's review a little bit. So solids are regular and they have an organized pattern, right? They're next to each other in the same pattern. This pattern has a special name. It's called a lattice. So solids will often form these lattices and they are tightly packed together, right? Liquids, their particles are randomly arranged, right? There's not really an order to it at all, and they are loosely packed. So they're still packed together, but it's looser than a solid. And then a gas, the particles are randomly arranged and they are far apart. They are bouncing around. They have lots of energy, right? So now we know where their particles sit and how they're arranged, but how do they move? In solids, particles vibrate about their position in the structure. So we imagine this like 3D picture of a solid and its nice lattice structure, its organized structure. How are these particles moving? They are vibrating up and down, back and forth. They can vibrate really in any direction. Um, why do solids vibrate? Why do they vibrate? And are objects ever perfectly still? I want you to think about both of those questions. Take a moment, maybe pause the video and write down answers in your notebook. So, solids have energy. All matter has energy, right? All the matter everywhere has energy. And if something has energy, it will move. So all of these particles have some kinetic energy, some moving energy, and so they are always vibrating. Um, and if it didn't have kinetic energy, it would be super cold, right? Because kinetic energy is related to temperature. Are objects ever perfectly still? No, they are not. There is a theoretical perfectly still called absolute zero. When the temperature is zero, there's no more motion. But in reality, that doesn't happen. There's always some amount of energy to make these particles move. For liquids, the particles slide past one another and move with a random motion throughout the container, right? So they are moving all over the place. And then gases, the particles move rapidly in all directions, colliding with each other in the sides of the container. Right? So there are collisions constantly with these gases because they have so much energy that they can go in any direction that they choose. So, as we think about our three states of matter and we think about energy and motion, we can also think about these states of matter changing from one state into the next state, right? And we can think of that happening because of heat energy, right? So as we increase the heat, we get changes in state of matter. So if you heat up a solid, you heat up a cube of ice, it will melt, right? And it will become liquid water. If you keep heating up that liquid water, it will vaporize, which can happen as boiling or evaporation, right? So the liquid will eventually become gas. If you start to take away heat, cool it down, that gas will condensate and become a liquid. You keep cooling it down, that liquid will freeze and become a solid, right? So this is our changes of state or our changes of phase. So we know what a solid is, we know what a liquid is, we know what a gas is, we know how their particles move, how they're arranged, and what happens when you give them heat and take away heat. You get these changes of state, right? So you should know these. We're going to talk about these some more, but I want you to make sure that we're getting all this new vocabulary down. So you're going to take a look at your worksheet now, and you're going to do your best on that. And hopefully I will be in Italy soon, and we can keep talking about solids and liquids and gases and all the wonderful, amazing things that chemistry has to offer. See ya.